Last day I was discussing the class A power amplifier, series fed class A power amplifier. So this is the circuit diagram for series fed class of A power amplifier. In this series fed, your load. Wait a second. In case of series fed, your load is connected in series with the output terminal. So this is the series fed class A amplifier. We whatever we see in the class A series fed power amplifier, this is the waveform. This one is the input waveform. This and this is the output waveform. This is current waveform, and this is the voltage output waveform. Okay. And after that, we go for the calculation of efficiency. So for finding the efficiency, first we find out the input power, input DC power. Then we find out the output AC power. And after finding output and input power, we are finding the efficiency, and efficiency equal to output power by input power, and it is equal to 25%. Okay. So that much we discuss in the last class. Now, in case of class A series fed amplifier, you can see the efficiency is 25%. So 25% efficiency is very less efficiency. So we want to increase the efficiency of the power amplifier, and for that reason some other circuit is used, and it is the transformer coupled class A power amplifier. Here we use the transformer for increasing the efficiency. Is it okay? Up to this, any query? Any issue? Yes, no? Is it okay, everyone?
Yes, sir.
Okay. So next, so if you compare the circuit diagram for transformer coupled class A amplifier and series fed class A amplifier, you can see just where the load is connected in series fed amplifier, at that place there is a transformer. A transformer is connected at that place. Means whatever the terminals at which we are connecting the load, this terminal is replaced with transformer. All of you know, in case of transformer, there are two sides are there. One is the primary side and other is the secondary side. I think all of you study about the transformer in your first year. Yes, no? Hmm?
Yes, sir.
Yes. So if you remember the transformer, so in case of transformer, there are two coils are there. So this is the primary side, or primary coil is there. This is the primary coil and this is the secondary coil. Primary side, secondary side. So here in this case, this is the terminal of primary side and this is the terminal of secondary side. Okay. So your primary side is connected at this terminal. Clear? Okay. And whatever the load in series fed, that load is connected at this terminal. Okay. This is very small change if you compare these two circuits. Clear? Now, same across the primary side, the voltage is V1. Across the secondary side, the voltage of the transformer is suppose V2. Your V2 is equal to V0 here. V2 equal to V0 here, and V1 is the voltage at this terminal, primary coil. Circuit is clear? And rest all parties same as series fed amplifier. Reply, is it okay?
Yes, sir.
Next is there are some properties or features of power amplifier, not power amplifier, transformer, and I think all of you know it. First is the voltage transformation. So in case of voltage transformation, if suppose N1, N2 is the turns ratio of the coil, you know the turns ratio of the coil, okay? And V1, V2 is the voltage across the primary side V1 and voltage across the secondary side is V2 voltage. Then your V2 by V1, the relationship for the voltage, input and output voltage, it is equal with the turns ratio. So V2 by V1 equal to N2 by N1, where N2 is the turns ratio of secondary side and N1 is the turns ratio of primary side. Is it okay? ये फॉर्मूला तुम लोग फर्स्ट ईयर में भी यूज कर चुके हो. Clear? So this relationship shows that how this voltage is transferred in case of transformer. Okay, so if you supply the voltage across primary side V1, you are getting the output voltage V2. And what is the relationship between this V1 and V2? It is V2 by V1 equal to N2 by N1. Is it okay?
Yes, sir.
Okay. Next is the current transformation. ये भी था फर्स्ट ईयर में current transformation. हाँ ना?
हाँ सर.
था. So in case of current transformation, if you provide the input current I1, then and you are getting the output current I2, then I2 by I1 equal to N1 by N2. This is the relationship for the current with turns ratio. I2 by I1, I2 is the current in secondary side, I1 is the current in primary side, and this is equal to N1 by N2, where N1 is the primary coil turn ratio, number of turns, and N2 is the secondary side number of turns of coil. Okay, so this is the current transformation. Next is the impedance transformation. Have you studied about the impedance transformation previously? Yes, no? So in case of impedance transformation, if you connect this if you connect the load across the secondary side, then what is the effect of this load at the primary side? It will decide by the impedance transformation. You can see this in the impedance transformation. So if I2 is if you load suppose RL, it is connected across the secondary side, then suppose it is RL is equal to R2, then what is the effect of this load across the primary side? You will get from this impedance transformation. So here R2 by R1, R2 is the resistance across the primary side and R1 is the resistance across the R2 is the resistance across the secondary side and R1 is the resistance across the primary side. Okay, R1. So R2 by R1, this is equal to what? R2 is equal to V2 by I1, V2 by I2. So R2 equal to what? Voltage across the secondary side divided by current across the secondary side. So R2 equal to V2 by I2. Same your R1 equal to what? R1 means resistance across the primary side So this is equal to resistor voltage across the primary side divided by current across the primary side, V1 by I1. So after this simplification, you will get V2 by V1 dot I1 by I2. V2 by V1 we are getting from the voltage transformation. This is V2 by V1 equal to N2 by N1, and I1 by I2 equal to N2 by N1. So this R2 by R1 equal to N2 by N1 whole square. Okay. So you are getting the relationship for primary resistance or primary coil impedance and secondary side impedance. Okay, that means if you put the RL across the secondary side, then what will be the effect of this RL across the primary side? Suppose it is R1 or RL dash. So this, what is the effect? You will get the relationship R2 by R1 equal to N2 by N1 and whole square. Okay. Now suppose RL dash is the resistance across the primary side and RL is the load resistance. So RL dash by RL, this is equal to R1 by R2, and R1 by R2 is equal to N1 by N2 whole square. R2 by R1 equal to N2 by N1. So R1 by R2 equal to N1 by N2 whole square, and suppose this is equal to A square. So here your A is equal to what? A is equal to N1 by N2. Okay. So you are getting RL dash by RL equal to A square or RL dash by RL equal to A. Is it clear up to this? Voltage transformation, current transformation and impedance transformation. Any issue? Yes, no?
No, sir.
ठीक है? प्रॉब्लम हो रहा है या ठीक है?
सर ठीक है.
ठीक है. अच्छा, next there is some problems from this topic. So first problem is calculate the effective resistance seen looking into the primary of 15:1 transformer connected to the 8 ohm load. So here what is given? Load is given 8 ohm. Transformer turns ratio is given N1 by N2 equal to 15 or 15:1. So and you have to find out the effective load across the primary side. So RL dash is equal to A square into RL. You use the formula, this formula, RL dash equal to A square RL. You have the N1, N2, N1 by N2 equal to 15 or 15 by 1. So 15 by 1 whole square into 8, and this is equal to 1.8 kilo. That means if you put the across the secondary side, if you put the load of 8 ohm across the primary side, its effective load is 1.8 kilo. Clear? Is it okay? If you face any issue, you can ask. अगर ज्यादा हो जाए तो भी बता देना कि सर आज के लिए ज्यादा हो गया है, क्योंकि काफी टाइम बाद तुम लोग ऑनलाइन क्लास कर रहे हो, तो मैं समझ सकता हूँ if you are facing issue. So up to this, any issue or okay? Yes, no?
Okay, sir.
Okay. Just use the formula. You are getting the 1.8 kilo ohm. What is 1.8 kilo ohm? It is the effective load resistance across the primary side. Means if you put the load across the secondary side 8 ohm, its 8 ohm put effective load across the primary side is 1.8 kilo ohm. Here. Now next is same type of problem it is. what transformer turns ratio, you have to find out the transformer turns ratio is required to match a 16 ohm speaker load so that the effective load resistance seen at the primary is 10 kilo. So prime speaker resistance is 16 ohm. So speaker is connected across the secondary side. Okay. So this is your 16 ohm is your load and its effective load is 10 kilo ohm. Then what will be the turns ratio? So RL dash is given 10 kilo ohm, RL is given 16 ohm. You put this, you will find the N1 by N2 whole square. Clear? So after this calculation, you will get N1 by N2 equal to 25. That means N1 is to N2 equal to 25 is to 1. Clear? Very simple it is. Just use the formula RL dash by RL equal to A square, where A square equal to A1 N1 by N2 whole square. एक ही फॉर्मूला यूज करके अभी तक हम लोग चल रहे हैं. जस्ट दिस फॉर्मूला. Is it
सर इस
clear?
टाइप से सिर्फ न्यूमेरिकल्स टाइप ही
Yes,
आता है या
sir.
फिर थ्योरेटिकल भी आता है?
ये बेसिक है. ठीक है, ये आपके ऑब्जेक्टिव में 1 मार्क्स का आ सकता है.
तो मतलब इस टाइप के क्वेश्चन से सिर्फ न्यूमेरिकल्स टाइप ही आता है?
हाँ, ये बेसिक है. इसमें इससे कोई बड़ा क्वेश्चन नहीं आएगा. ये जस्ट ट्रांसफार्मर का बेसिक है. अब अभी तक जो हुआ है इस पोर्शन, मैंने इस पोर्शन में आज के, क्लियर? अभी हम लोगों ने इसमें क्या कहते हैं, पावर एम्पलीफायर में इंटर नहीं किया. अभी तो हम लोग ट्रांसफार्मर में ही है. इज इट ओके?
सर.
ओके. अब चलो पावर एम्पलीफायर में. पहले ट्रांसफार्मर थोड़ा समझ लिए, उसके बाद पावर एम्पलीफायर. नाउ सी, in case of class A, what transformer coupled power amplifier, class A transformer coupled power amplifier, here you can see the transformer winding resistance determine the DC load line. देखो, ये in case of transformer or in case of power amplifier, in case of power amplifier, not transformer, in case of power amplifier, you can see here the input signal is your DC. Sorry, not input signal. Here the power supply is DC. This is the DC power supply, and this VI is the signal voltage. Basically, or most of case, your signal voltage is AC signal, and this is supply voltage is DC signal. Okay, and there you can see there is a capacitor. What is the use of this capacitor? This capacitor basically separates the AC and DC component of the signal. Okay. So now in this case, here here the DC resistance is small. DC resistance of the circuit is small, close to 0. So there is no DC voltage drop across the load resistance. Okay, and the load line drawn straight vertically from the voltage point VCQ y equal to VCC. You can see here the load DC resistance is very small. So here this is first select the Q point. Where we select the Q point? Same as series FET. We select the Q point at the middle of the AC load line. This is the AC load line, and we select the Q point at the middle point. And your DC load line, it is perpendicular to Q point since DC load resistance is negligible or close to 0. So first we select the Q point at the middle of the load line or AC load line here. Same as the previous class, along this axis there is your input waveform. Here input waveform is not shown in this figure. You can show, no issue. Across the this axis you can see this is the voltage, output voltage waveform, and this is the output current waveform. Same as the last class. Is it okay or not?
Okay, sir.
ठीक है. same waveform, you can see this waveform is one thing here. When we connect the when you put the AC load line, we select the AC load line in such a way that it cuts the x-axis at 2 VCC. Okay, VCC is the input DC voltage or power supply voltage, and this axis is cut at the 2 VCC. Just one thing change here. So this is the 2 VCC. Next, from Q point we draw the perpendicular on y-axis. This point is ICQ, same as before. From Q point we draw the perpendicular. It is VCEQ. This point, middle of this axis. This is also middle of this axis. Clear? So along this axis we draw the current, and along this axis we draw the voltage waveform, output voltage waveform. Same as previous, VC max is the maximum voltage, VC min is the minimum voltage. Along the current axis, IC min is the minimum voltage across the current, and IC max is the maximum voltage across the current. Clear? Maximum voltage कहाँ तक जाएगा, maximum current कहाँ तक जाएगा, maximum current is reached maximum up to this and minimum is up to this. Same your voltage is minimum reached to this line and maximum reached to this line, as we discussed in the theory class. Clear? और अगर यहाँ इनपुट वेवफॉर्म ड्रॉ करना है तो यहाँ पे कर सकते हो, कोई इशू नहीं. You can draw the input waveform like this. Up to this, okay?
Yes, sir.
ठीक है. Next, जो हम लोगों ने लास्ट दिन क्लास में किया था वही चीज. VC peak to peak. VC means along the output voltage axis. This peak to peak voltage, maximum peak to peak voltage. तो मैक्सिमम ये कहां तक जाएगा, मैक्सिमम इट इज रीच टू दिस पॉइंट. इस टाइप से मैक्सिमम होगा. तो दिस इज द मैक्सिमम पिक टू पिक वोल्टेज अलोंग द वोल्टेज एक्सिस. तो वीसी पिक टू पिक इक्वल टू वीसी मैक्स माइनस वीसी मिन. तो दिस, इफ यू कंसिडर दिस वेव फॉर्म तो दिस इज द मैक्सिमम, एंड इफ यू कंसिडर दिस वेव फॉर्म तो दिस इज द मैक्सिमम. क्लियर? तो इन आवर वेव फॉर्म दिस इज द मैक्सिमम peak to peak voltage. This is the peak to peak voltage. So VC peak to peak equal to VC max means this one minus VC min means this line. Okay. Same IC peak to peak. IC peak to peak means for our waveform this is the IC peak to peak current. Clear? And VC min maximum reach to this point and IC max maximum reach to this point. So IC peak to peak equal to IC max माने this one minus IC min means this one. Clear? Peak to peak we also discussed in the last class. Reply करो, आगे बढ़ना है ना. अगर if you face issue then you can talk. I will discuss again. समझ में आया या नहीं आया? यस नो?
आ गया सर, समझ में आ गया सर. एक्चुअली लगता है मौसम की वजह से सबका इंटरनेट स्लो है, तो हो सकता है इसलिए से प्रॉब्लम हो रही होगी.
अच्छा, अब देखो मैं क्या कहता हूँ. अरे तुम लोग को रिकॉर्डिंग प्रोवाइड कर दूंगा, ठीक है. आई विल प्रोवाइड यू द रिकॉर्डिंग. और मौसम के बारे में तो मुझे पता नहीं, मैं तो रूम में बैठा हूँ. ठीक है. नेक्स्ट आउटपुट एसी पावर.
सर
हाँ बोलो.
सर आप पार्टिसिपेंट से रिमूवल ऑप्शन ऑफ कर सकते हैं, क्योंकि कुछ ही सेकंड पहले मेरे को किसी ने रिमूव कर दिया था और अभी मैं ज्वाइन हो गया.
वेट ए सेकंड, ये कहाँ से करते हैं बताओ.
सर मेरे को पता नहीं किसी ने करते था. आप
मुझे खोजना पड़ेगा फिर.
सेटिंग्स में आप देखिए, क्योंकि उसी टाइम पहले
तुम लोग बड़े हो गए, वैसा मजाक बंद करो, ठीक है। हाँ, अब ये सब छोटे छोटे बच्चे करे तो समझ में आता है, तुम लोग इतने बड़े हो गए फिर भी ये सब छोटे, कोई किसी को रिमूव नहीं करो। मैंने सारा एक्सेस सबको देकर रखा है, इसका मतलब उसका गलत यूज नहीं करो। अब मैं खोजने बैठूंगा तो फिर टाइम लग जाएगा फिर। ओके, एक दूसरे को हेल्प करते हैं, कोऑपरेट करते हैं, ये सब आउट करने वाला कौन सा काम है। चलो, आउटपुट एसी पावर, सेम फॉर्मूला वी डिस्कस इन द क्लास, लास्ट क्लास। VC RMS value into IC RMS value. So output AC equal to voltage across the output side into voltage current across the output side. VI, so VC RMS, IC RMS. Same we discussed in the last class. VC RMS equal to VC peak to peak divided by 2√2 into same IC peak to peak divided by 2√2. Peak to peak means VC max minus VC mean. IC peak to peak means IC max minus IC mean. So after this, you will get VC max minus VC mean into IC max minus IC mean divided by 8. So this is the output AC power you can get up to this. Next is maximum output AC power. What is the maximum output? So when you are getting the maximum output, when your output side voltage is maximum and input and output side current is maximum. So when the output and side voltage and current is maximum, that means here your this VC max is reach up to 2 VCC. So you put the VC max 2 VCC and VC mean it is reached to 0. So it is reached to put 0, you put the 0. Same for the current. This IC max is reached to this point and IC min is reached to this point. Now this IC max is reached to this point. That means ICQ is the middle of this point, this axis, middle of this line. So this point is 2 ICQ. This point is 2 ICQ. Means here this is the middle point and it is ICQ. That means this is 2 ICQ. Clear it is? So you put IC max is 2 ICQ and IC min is 0 for the maximum efficiency. So you are putting this, you are getting 4 VCC ICQ divided by 8 and this is equal to VCC ICQ by 2. So you are getting output AC VCC ICQ by 2. You are getting this value. Clear?
Yes, sir. Clear.
Achha. Next, input DC power. We discussed in the previous class, input DC power equal to VCC into ICQ. Same. Next, we finding the efficiency. So efficiency equal to output AC by input DC. Put this value for output AC and input DC. You are putting the value into 100 for the percentage. Here you are getting the efficiency 50%. So previously the efficiency was 25%. Now if you are using the transformer coupled power amplifier, then the efficiency is changed to 50%. Okay, so it is almost double compared to series FET. Is it clear? Next, if you finding the efficiency in your problems, then you use this formula. अगर efficiency proof करना है तब तो वो 50% निकालोगे. But if you are using you have to find out the efficiency in problems, you will use this formula. Efficiency equal to 50 into VC max minus VC min divided by VC max plus VC min whole square. You will get in terms of percentage if you use this formula. Clear? Next, one problem from this topic. Up to this, okay? I will share you the notes. As I discussed in the class, from this topic, what type of question you will get? You will get the explanation about the transformer coupled class A power amplifier, its circuit diagram, its waveform, input output waveform to this waveform, and efficiency calculation. Okay, so you have to derive the efficiency here. So this type of problem, your questions you will get from this topic. You are getting long question from class A power amplifier. Up to this, okay. Next is one problem from this topic. Calculate the AC power delivered to load given that VC mean value is given, IC mean value is given, VC max value is given, IC max value is given. We have to find out what? Calculate the AC power delivered to load. Achha. What is the power delivered to load? You have to find out. Also calculate DC input power dissipated. Across the input power, how much power is dissipated by the transistor. Achha. Given that VCC is 10 volt VCC given, and ICQ is 140 milliampere. Find the power loss and efficiency of the circuit. So first, output AC is, you have the formula VC max minus VC mean, IC max minus IC mean by 8. You are putting the values are given. You are getting output AC power, this value. Output AC power, you are getting this. Next, input DC is what? You are using the formula VCC into ICQ. You are getting input DC power. So after getting input power and output power, then you can find the power loss. कि कितना पावर नुकसान हो गया. इनपुट में मैंने पावर दिया 1.4 वाट एंड आउटपुट में पावर मिल रहा है 0.477 वाट. तो इसमें पावर कितना लॉस हुआ? You will get by subtraction. So you will get this amount of power is lost in the transformation. Okay. Next is the efficiency calculation. So efficiency calculation is output AC by input DC into 100. You put the value and it is 34.1% in this case. Clear? If you're facing any doubt, you can ask. Just use the formula and basic concept here. You will able to solve the problem related to power amplifiers. Is it okay? अच्छा.
Yes, sir.
ठीक है, अब आज के लिए इतना ही रहने देते हैं. अगर किसी को कोई डाउट है तो पूछ सकते हो. I will share the notes from you. I will share the recording from you. And if you face any issue, you can ask. अभी पूछ लो या फिर क्लास में भी पूछ सकते हो. Is it clear to everyone?
Yes, sir.
Yes, sir.
ठीक है, रुको अटेंडेंस कर लो. इसके स्क्रीन ऑफ करूँ तो?
Yes, sir.
पहले एक सेकेंड, रिकॉर्डिंग स्टॉप.